So going back to question 9, and in order to be able to sketch the derivative function, we will go through a process which will help you understand what the derivative function is. Let's remember first the definition of a derivative. Anyone in easy words, in your own way. What's the derivative?
The slope of the tangent.
Slope of what?
The tangent.
Tangent line, okay? We're not talking about secant line. So derivative is the slope of tangent line. Before we start, if you look at this curve, it's a function, right? A function, we don't know its equation. Tell me how many tangent lines can be sketched for this function. How many tangent lines can be sketched for this function? No ideas? Farida. How many tangent lines can be sketched for this function?
Yes, we can sketch one for each point.
One for each point. How many points are there?
How do I know that?
How many points does a function have? Any function?
Infinite.
Infinite. So the conclusion is how many tangent lines can we sketch?
Infinite.
Infinite amount of tangent lines, which means that, and each slope is going to be unique. So it means that there will be infinite amount of slopes, right? So this is the first idea to think about. Let's go back to question 9, which you were asked to complete at home. So can you see my screen well now?
Yes.
Right. So yesterday we stopped at this formula. So this formula represents the derivative function for the given cubic function. And we also sketched both. F of x is in red. I don't know why I have f prime of x is in blue. So in fact, this f prime of x, let me change the color here. And if you don't have it, sketch it quickly. So I will, yeah, Noor?
I'm really sorry I'm late. I didn't realize the time. Sorry.
Okay, so we are recording the session. We will complete it, and then I'll take attendance at the end. So right now we're discussing question 9, which you were asked to complete at home, and I'll just label it properly. So this is f prime of x, and this is f of x in red. We're going to go through a certain process, which I hope will help you to understand more about derivative function. Okay, so before we start, what is the original function? What is the algebraic representation of the original function, the one which is in red? Noor, Gennady, what's the algebraic representation of the original function?
Okay, it's a cubic function.
Cubic function, but not just a cubic function. So what's the equation?
A parent function.
It's a parent function, so x to the power of 3, this one. And Omar Ismail, so what's the equation of the derivative function?
The equation is f prime x f prime of x 3x power 2.
Mm-hmm. How can you describe this function? What type of function is it?
The quadratic function.
Quadratic function, absolutely. So now we're going to do the following. We are going to think about inputs and outputs of the original function and derivative function. Okay, so we'll start with the original function, of course, and this is what you were supposed to do at home, to find the slopes for each of the following points with this x coordinates. Right. So I want to
ask. So we just substitute it, correct?
Yeah. So f of -2. What is f of -2? Where are you supposed, Mohammed, to substitute -2? In which equation? If I'm asking about f of -2.
In the f of x is equal to x.
So what is the output?
It's going to be -8.
Yeah, it's -8.
Okay. Now, this is x, right? And keeping the same x here, we are going to analyze what's the output for f prime if x is equal to -2. Farida, what's the output for this function?
We're gonna send it into the derivative function of dx, right?
So what's the output?
Are you asking for -1?
Negative what?
Are you asking for -1? I can't see.
I'm asking what's the corresponding y value for this x?
3.
3. Where are you inputting the x equals -2?
Oh, I'm looking at the -1. So
No, -2.
okay. It's going to be 12.
12. Let's move on. F of -1. Noor Ginedi, f of -1.
Yes, miss.
What's f of -1?
It's -1.
-1. Omar, what's f prime of -1?
3.
3. And one more time. Last time. Mina, f of 0.
It's going to 0.
0. And Mina, what's f prime of 0?
0.
Is 0 as well. Good. Now, we will move and analyze this. We will move to the graph and analyze this data on the graph. So I'm taking x value. As you can see, x values in both functions, which we are taking as inputs, are the same. Okay? So we'll start with -2. So let's say that x equals -2 somewhere here. Let it be here. Okay? This is -2. Right. In order to get the corresponding y value of -8, should I drop the perpendicular to the red curve or green curve, Mohammed? To get -8, should I drop the perpendicular to the red curve or green curve? Like this or like that?
The red one.
The red one. So if I drop the perpendicular here, you understand that this is a sketch. Of course, it's like, might not be accurate. 20 minutes, okay? So that's gonna be -8. Now, if I want to, my next question is, if I want to sketch a tangent line to this point, which slope is it going to have? What is the
A
value?
negative slope.
Hold on. Again, if I'm going to sketch a tangent line here, let me sketch it. And you think before you jump into conclusion.
Positive, because it goes from left to right, the graph.
At least it has to be positive, because we see it's rising, right? It's going up. It's like this is rising. It's an increasing function here. So good comment, Noor. So, but Noor, can you say right away what is the value of the slope here? What do you think is the slope?
4.
4?
Yes.
Why? Explain.
Because I took the x value and then divided it by the y value.
You mean rise over run?
Yes.
He divided -8 by -2.
Should be 1/4.
No. Okay, no, this is not how you do it. So once again, the information is here. So what is the slope of this tangent line?
The derivative equation.
Which is not equation. Slope is the constant. What's the m for this curve? Sorry, for this tangent line. When x is negative 2?
12.
12. Absolutely. As you can see, derivative is a slope. When x equals negative 2, the derivative value, which is y value, is 12. And what does this 12 represent? The slope. The slope for each and every x value here, right? Let's do it again. Let's do the other thing. Now, where should I go from negative 2 in order to find the corresponding 12 as y value? Where should I go? Where should I find it? On the graph.
Wait, can you ask the question again?
Where?
Can you ask the question again?
Yeah. My question is, on the graph, I want to find also this ordered pair, negative 2, 12. So where should I go in order to find this corresponding 12 on the graph? Where should I move from negative 2 in order to find the corresponding value, 12?
Do we look at the derivative from
So I drop the perpendicular to which color of the curve?
the green?
The green one. So if I drop the perpendicular here, I will find the corresponding y value of 12. So this is how the ordered pair look like on the derivative function. And this is how it looks like for the original function. Let's keep going. Next point, negative 1. So let's say, I hope now it will become a bit faster. Negative 1 is here. Let's say it's here. Negative 1. Nur Fahmi, what's the corresponding y value for the original function here? What's the
Negative
value?
1.
Negative 1. If I sketch the slope, what is going to be the slope value? Sorry,
Three.
it's the tangent line. What is going to be the m of this tangent line?
It's going to be 3. Positive.
It's going to be 3. And as you can see, if I go from here up to the green curve, which represents the derivative function, then I will intersect somewhere here to get 3. Okay? And finally, last step, 0. Right, so if I am looking into the x equals 0 here, x equals 0 here. Let me take something. I'll take blue, okay? So if I take the x value, 0. What is going to be the output, Omar? What is the corresponding y value?
Miss, did you say Omar or who?
I said Omar, yes. I am asking if x equals 0, what's the corresponding output?
It's going to be 0. So
Also 0, so it's here. Now, because here it's a bit crowded, I'll take the curve like this. So the red curve at origin is actually like this, okay? Where this is where the origin is. Tell me how the tangent line, Omar, will look like for this point. Omar, do you know?
Yes, it's going to be horizontal.
Absolutely, it's going to be horizontal. And what do you know?
Y equals 0.
What is M for the horizontal line?
And for horizontal line is 0.
0. And this is confirmed here. F prime of 0 is 0. And as you can see, for the parabola, which represents the derivative function, the vertex is at 0, 0. So this is the point which is for x value of 0. The corresponding y value is also 0. Okay, so now conclusion. So the conclusion is that when we compare the original function and the derivative function, we take the same x values. So we keep the argument or x values the same for the original function and derivative function. And the outputs for the derivative function are all possible slopes of tangent lines to those points with those x values. So having this in mind, like this first concept, we're going to first practice matching the original function graph to the derivative function graph. And the next stage is when the graph is given like this one, we will end up with having this graph of the original function f of x. So we need to, based on what we see without the formula, we need to sketch the derivative function. Okay, so right now we're working with question 15, page 75. Please write it down. So in this question, on the left, we have functions, original functions. So on the left, it's f of x, 3, right? Just a second. F of x. And on the right, we have f prime of x. So we need to match them, okay? Right, so we will start with A, which is the, how would you describe this function, Farida? What do you know about this function?
A reflected parabola.
It's a parabola which looks where?
Reflected. Down, yeah, reflected.
Which is reflected. Okay. Now, before you start thinking about which one is the corresponding derivative function, I want to do only just one process with you. Tell me, moving from left to right as usual, what is the interval where the function is increasing, this function, and what is the interval where this given function is decreasing? Mohammed, will you be able to state it? So when is the function increasing? On which interval for x?
From negative infinity until 2.
Until 2? For
Yeah.
x, Mohammed, we state the interval for x.
Until 0.
Until 0. Including the 0 or excluding 0? Rising.
Excluding 0.
Including? Excluding.
Yeah.
Excluding 0. We'll speak about 0 later. Now, where is the function decreasing, Noor Fahmi?
From 0 till infinity.
From 0 until positive infinity. Now tell me, how can you describe, so the next question is, when the function is increasing, what can you say about the slopes, all those slopes which are possible for the tangent lines here? Are they positive or negative?
Positive.
They are positive. Positive slopes. Where that means that if it's decreasing, then they have negative slopes, right? Okay, now tell me what will be the slope at 0 when x equals 0? What is going to
0.
be?
0.
The slope is going to be 0. Slope is 0. Okay, so this is the analysis you should always do whenever you need to sketch the derivative function given the graph of the original function, okay? The other thing which you need to think about is this one. Slope is 0. The slope value for the derivative function is y value or x value? Once again.
Y.
So you have x and y for any function, and derivative function is not an exception. So the slope, all those slopes we were talking about of this function are going to be the set of y values, right? So y values are the values of the slopes, or the values of the slopes. Okay? Okay, given this idea, tell me if the slope is 0, What kind of, how can you describe this point? It's a special point for the derivative function. What's the name of it? Which means that the y value is 0. What's the name of this point? When the y value is 0. For any function.
Is it in the derivative or like
Anything. We're talking about function. Function is a general concept.
X-intercept.
X-intercepts. Great. X-intercepts. Okay. So this is crucial. It's very simple and straightforward, but it's not like once you see derivative, commonly you forget about the function, but derivative is just a function, just like any other function. Okay. So everything you know about functions work here as well. Okay. So let's now try to match. So which of those graphs you think is representing the derivative function for this parabola? Do you have an answer, or should I keep asking, giving you clues? Yes?
is it E?
D? No.
E.
It's E. Can you explain why you think that it's E?
Because I realized the function, the original function is always the derivative function is always like has a less what's it called?
No, you are moving ahead and you are using algebraic idea about derivatives. We're not working here with the algebraic representation. We're working only with our understanding how slopes look like for the original function. Okay, let me ask you another question. So if here the function is, as you said, all the way until 0, slopes are positive. If slopes are positive, it means where the derivative function should be located, above x-axis or below x-axis?
Above.
Above x-axis. So check those three and decide which one, which functions, which graphs match this condition that it's until 0, it has to be above.
I think it's E.
So it's E and F, right? We don't know yet, but do we see that in E and F, until 0, the curve is above, right? So now we need to choose between E and F. How? By checking the second interval. So in the second interval, the slopes are negative. It means that the y values are negative. It means that the function, the derivative function, is going to be above x-axis or below. When y is below. So is this below?
Yes, so it's E.
Is this below?
No.
No. So it means that this is the one which checks, right? These conditions. Plus, what's important to notice is that, didn't we see that at x equals 0, the slope is 0? It means what is going to be, what's the meaning we get from here for the derivative function? That it's an x-intercept. Look, does it intersect the x-axis at 0? Yes, it does. Okay. Let's move on and consider this function. So we're working with B now. Right. Okay, so same idea now. Let's analyze the slopes and when are they negative, positive, and when are they 0, okay? So, Mohammed, all the way until 0, are the slopes positive or negative?
Positive.
Positive. Does this mean that the derivative function is going to be دي واحدة لو سمحتي ممكن 10 دقايق شكرا. So it means that the derivative function is going to be above x-axis or below x-axis.
Above.
This interval, above. Now let's analyze the second part. Is it increasing or decreasing function here, Mohammed?
It's also increasing.
So it means that it's going to be above x-axis or below?
Above.
And where is the slope 0?
At 0.
At 0. So which function, d or f, is representing the derivative?
It's F.
It's f. Okay, and finally, so this is for B, right? Finally is C. Okay, yes, we know that C is D. 1 second. Get ready to tell me where the slopes are negative, positive, and where the derivative function is going to have x-intercepts and y. Okay, so let's move on from left to right. So from left to right, is this increasing or decreasing?
Decreasing.
Decreasing. So tell me, Farida, where is the first interval going to stop where the function is decreasing?
At -2.
At -2. So I always recommend doing this, breaking up the x-axis into intervals according to the behavior of the function. So it's decreasing means the slope is negative or positive?
Negative.
Negative. So I put minus here. The next interval, so and they will be always, most of the time, most commonly they will be switching, right? So Noor, the next interval. What is going to be the next interval? And Noor Ginedi, yes, and describe the slope, positive or negative.
Okay, next interval is going to be positive, from -2 to 0.
From -2 to 0, absolutely. So this is the next interval. Next interval, Noor Fahmi.
Miss, can I
Yes,
say?
Mr. Fahmy.
No, next interval.
From 0 to 2.
From 0 to 2. Is the slope negative or positive there?
It's 0.
Look, from 0 until 2. Is it a negative slope or positive?
Oh, it's negative.
It's a negative slope. And finally, the last one, Mina. The last interval. From where to where?
From 2 to infinity.
From 2 to infinity. What can you say about the slopes?
Positive.
Positive, absolutely. So now we know minus, right? Negative slope means below x-axis for f prime, right? And positive means above. So this is the first important piece of information. And the second one is x-intercepts. So the x-intercepts, Farida, for f prime,
They're
In the
0, -2, and 2.
So from left to right, negative
-2,
2,
0, and 2.
and 2. So given all of this, let's go back and just to the derivative function, just make sure that this is the true. So check the x-intercepts. Do you see that they are -2, 0, and 2, just as we said, right? And then negative slope, so below x-axis until -2, yes. Here it is, until -2, below x-axis. From -2 until 0, positive, above x-axis. And then from 0 to 2, negative, below x-axis. And finally, from 2 until infinity, positive, so it's above x-axis. Okay, so we are moving to the last stage where now we're going to sketch the derivative function based on the given function. I highly recommend that you sketch this curve in your notebooks right now. So we're going to work with this f of x. So let's describe it. As you can see, we don't have any numbers. But what is significant about this function? How could you describe it? Any features which you would like to mention? For example, how many minimums does it have? Local minimums?
2.
2. So this is the minimum and this is the minimum. How many local maximums does it have?
1.
1. Why is it important in terms of the derivative? Why is it important in terms of the derivative function? Minimums and maximums.
To know the power.
Mohammed?
I wasn't
Let me put it in a different way. What can you say about the tangent line slope in at those values?
0.
0. So the maximum and minimum of f of x are, complete the statement, Farida, are, so the maximum and minimum of f of x are, complete the statement. Noor Fahmi. Maximum and minimum of f of x are, what are they for f of x? Or for f prime of x? Who can do it? Who can try? Mohammed? You just said it.
Oh, it's 0.
So are zeros or x-intercepts for f prime. That's why they are significant, right? So it means that if I take those points and drop the perpendicular, I know that here, and here are the x-intercepts for f prime. Okay? Not only this, but also they are the values which are breaking up the x-axis into intervals according to the slopes values, either they are positive or negative. So if I break down now the intervals, this break up this x-axis into intervals, you will tell me plus minus, where plus stands for, second. So the first interval, is the slope positive or negative?
Negative.
Negative. The second interval.
Positive.
And the third interval.
Negative.
And the last one?
It's positive.
Positive. Guys, would you try to sketch, but use pencil? I'm giving you 1 minute to sketch the graph of the f prime. I will restart my application. Okay, it's working now. I'm giving you 1 minute to try and sketch it yourselves. And then after 1 minute, I'm going to complete it and you will compare. Okay? So 1 minute, try to sketch it yourselves.
Miss Natalia, isn't it gonna be like D?
Like what?
Like D.
Like D. It's very close to D, yeah, I agree. Probably it's even the same. You're right, yes. Okay, guys, the last thing which I hope that you have had an opportunity to sketch your own derivative function. I just want to highlight the last parts. So we don't know where exactly the derivative function, because we don't know precisely the value of y, and we don't know exactly the values of the slope. We just have to show the steepness, like relative to each other. What I'm talking about is, if you take the first interval, tell me where is the slope the steepest? On where on this interval the slope is the steepest?
When it intercepts the x-axis.
And then, but yeah, somewhere here. Okay, but anyways, on this edge, we can see that it's steeper, right, than here. Here it comes close to this point and to minimum, and at minimum it's 0. So it means that it's getting flatter and flatter, right? So, and here it's steeper. However, it's negative. So it means that here we have big negative values, right? So we start with big negative values. And then where should I come at the end of this interval for derivative? I should find myself here, right? At the because it's an intercept, as we said. So I start really low, somewhere down here, and then I come all the way until the 0. Okay? Now let's take the next interval. Tell me on this interval where approximately the slope is the steepest.
At the middle, like
In the middle, somewhere in the middle. And on this interval, is the slope positive or negative?
positive.
Positive. So Noor, if it's positive and it's the steepest, now think about the curve of the derivative here. What is it going to represent for the derivative function? Which kind of point? If not Noor, anybody who has ideas.
Big, it's going to be like large y values.
Yes, but don't you see that afterwards it becomes flatter and comes back to 0?
Yeah.
So what does this mean? It means it keeps growing, and then it again becomes less and less, increasing and then decreasing. So what is this point for the derivative? Increasing and then decreasing. What do you know about a point where before this point the function is increasing? After this point the function is decreasing. What's the name of the point? It's a maximum.
Oh, the maximum.
It's a maximum, absolutely. It's a maximum. So I'm going up until the maximum, and then I'm going down until 0 again. Okay? More or less the same, but like a reflection, right? It's a negative slope with the steepest slope in the middle, which means that this is going to be a minimum. And then back to 0. And then it's flat, close to 0, and then it grows up and up, which means that the slope is getting steeper and steeper, right? So after that, it's going to be growing like that. Okay? This is the curve of the f prime. Okay.